Okay, we're going to find the intercepts and test for symmetry here in problem 2, section 2.2. This is your equation. We're looking for the x and the y intercepts. Remember, when we look for the x intercepts, what will we do? We will let y be 0. I went ahead and solved this equation for y. I moved the x squared over. Whether you really do that or not, it does not completely matter. But I let y equal 0, so I had 0 equals x squared plus 49. So then I turned around and moved the x squared back over. If it equals 49, I took the square root of both sides. And remember that 7 squared is 49, but also negative 7 squared is 49. So you have two answers, positive 7 and negative 7. Those are your two x-intercepts. Your y-intercept happens when x is equal to 0. I went back up here. It's just a habit I have of solving things for y, and I replace the x with 0. Of course, the x term cancels completely out, and you're left with 49. So the actual three intercepts you have are here. Okay, then you go through the test. Your background for symmetry, a graph will be symmetric to the x-axis if you get an equivalent equation when all the y's are replaced with negative y. Replace y with negative y for x-axis symmetry. For y-axis symmetry, replace the x with negative x. And for symmetry about the origin, if we get an equivalent equation when all the y's are replaced with negative y and all the x's are replaced with negative x. So those are your three symmetries, x-axis, y-axis, and origin. If you replace y's with negative y's, you're looking for x. If you replace x's with negative x, you're looking for y's. If you do both, you're looking for the origin. So starting out, we are going to replace y with negative y, and this is what we get. This is not the original equation we had, so it is not symmetric to the x-axis. Then we'll come down and do the negative x. So we're doing the negative x, we're checking for y-axis. And notice that this equation is identical to what you started with, so it is symmetric to the y-axis. For the origin, you replace both. The resulting equation is not the same as the original, so it is not the equation is not equivalent to the original equation. Since it's not equivalent, then it is not symmetric to the origin. So the only symmetry you have here is y-axis symmetry. Okay, now I have produced the graph of this so that you can see it truly is symmetric to the y-axis. And notice in these two x-intercepts here, what happened? The signs changed to the x's, so that means it's symmetric to the y. Hope that makes a little sense to you.